All right. Hello, Twitch. My name is Colton Ogden, and I'm joined today by Kareem Zidane. Kareem, want to introduce yourself?
Yeah, hi everyone. My name is Kareem Zidane. I am a preceptor here at Harvard. I work here with CS50, mostly doing software development stuff, DevOps stuff, system administration. Yeah.
Nice, and some folks refer to you as Kareem the Dream. Is this correct? Shout outs to Spencer Taberry.
Some folks, yes.
Today we're doing the Kareem the Dream stream.
Okay,
So,
I did not see that coming.
And what are we talking about today on the stream?
We are going to be exploring a little bit of the basics of Git and GitHub.
Okay, nice. For folks unfamiliar, what is Git and GitHub? Sort of in a sentence or two.
So Git is a distributed version control system, also known as source control system. And Git is usually used to track changes in files and directory structures of our projects. And you can imagine this is quite handy for us developers because we tend to do a lot of changes, right? Like we always add features, fix bugs, refactor, improve stuff, and so on. So you can imagine this gets quite handy to keep track of these changes, be able to revert back to some of them, be able to build on top of some of them. Git also stores these changes really efficiently. Like it only stores the things that are necessary in this case. So we don't have to worry about like duplicating the whole code base that we have or duplicating all the files in our project. It only stores the files that changed. Another cool feature of Git is that it also allows us to work on different parts of the project at once if you want to, or different features at once. And this is also quite handy because you can imagine like we try to experiment with something or fix a bug or try to add a feature and we're not really sure if that's going to work out well or not. So Git really makes it easy as well to do this kind of thing. And lastly, Git also allows us to collaborate with other people pretty easily when used in particular with a hosting service like GitHub.
Okay, sure. And I know we use GitHub all the time in CS50, but for folks unfamiliar, why don't we want to show them what GitHub looks like and maybe just kind of give them a couple sentences of what GitHub itself is. I'm going to pull up our other view here,
Sure.
just so we can see. That's actually that is your computer? Okay,
That's
good.
my computer, yeah.
Perfect.
And this is how GitHub looks like. GitHub is a hosting service. We're going to talk a little bit about GitHub later. But this is what GitHub looks like. If you don't really have a GitHub account, you should probably go ahead and create one. Let me sign out of mine here. And if the internet helps, we go to github.com/join. You should be able to create a new account if you don't have one.
Okay. And so Git is like we use it, the command line or whatever, the actual tool, and then in GitHub is like sort of where we can like push our code and sort of store it and let other people see it and work on it, right?
True. Yeah, we're going to discuss this in a bit more detail later on. Git, yes, is mainly a command line tool, but it also has like graphical user interfaces if you'd like to use a graphical user interface. I personally use it on the command line, which is, I don't know, easier for me. But yeah, you can definitely download the graphical user interface for it and use it.
Okay, cool. Well, let's get started then.
Yeah, so the first thing that we need to do is, of course, get Git installed. And
Elias, hi Kareem and Colton. Hi Elias, good to see you again from Morocco.
Thank you so much.
Why don't you read, I can't see what it's in blue text. Oh, Irene says, why don't you read Irene's message there too?
If I'm not mistaken, if I recall correctly, her name should be pronounced as Irene.
Oh, Irene? Okay.
Yeah, but maybe, yeah.
Okay.
Please correct me if I'm wrong.
TIO.
Yeah, so yeah, this is really exciting for me as well because this is actually my first ever live stream. I've never been in a live stream before. So this is exclusive to you, Colton.
Oh yeah, this is true. Yeah, Irene basically said Kareem the Dream stream on screen.
Oh my God! Okay.
Just really building it up.
Why did you start this?
Hi Kareem, good to see you here, and hi Colton. Hi Irene, good to see you, or Irene if Kareem's pronunciation is correct.
Yep.
Oh yeah, you got somebody from Egypt.
Oh cool. Okay, hi, good to see you. I can't see the username quite well. Oh, Geek Nabil, I think I know him, Muhammad Nabil. All right, that's great. Hello from Spain. We have different people from all around the world.
Yeah, and then Bhavik is a regular as well. He's been on the game chain. Good to see you, Bhavik. Thanks for coming in again today. All right, so...
Okay, so the first thing that we need to do in this case is, of course, download and install Git. Git has installers for at least Mac OS, Windows, and Linux. I'm going to be using Linux, specifically Ubuntu 18.10. I don't know, maybe 18.10. I don't think it should make a difference how you install Git on Ubuntu in general. So the first thing that you need to do if you haven't done this already is to download and install Git. Maybe follow the documentation here on how to do that. In my case, I'm just going to do apt-get update to make sure that I have the latest, to make sure that my package manager knows about the latest versions of packages that are available. Apt-get install Git. This is how I think you would install Git on Linux. Yes, I'm sure I want to install all these dependencies, excuse me. And once this is done, to verify that Git is installed, you can just do git -- version, and it should tell you that you have Git.
By the way, just included the chat box. We were missing the chat box there in the video.
Okay, that's great. So now that we have Git installed, the first thing that we want to do is create a Git repository, or initialize a Git repository to be specific. And I think there are two cases here. The first case is that you're starting from scratch and you have an empty directory. Let's call this project or my project or whatever, and you can just go inside of this directory using the cd command. And the way to initialize this Git repository or project, or in other words, say, hey Git, I want you to track the changes in this project, is by running git init, and Git should reply initialize empty Git repository in root workspace, the path to your project, and then creates this .git directory that we're not going to really worry about it too much for now, but this is how we initialize a Git project. This should work pretty much the same if you already have a project in this case. So let me try to remove this project first. And I do have a thing for rush-IAMs. I'm going to use David's rush-IAMs example from lecture. So I'm just going to copy this recursively here. Okay, now I'm going to go do git init to initialize this project. And now we have Git tracking this project or this folder. A question that you would find yourself asking pretty frequently is, hey Git, what's the status of this project?
Sure,
what changed
yeah.
and what didn't change and so on.
I lose track definitely all the time if I'm making changes to files over and over again.
Yeah, so the way to do this is actually literally by running git status. And in this case, Git should tell us what changed and or what we have, what changed and what not in this case.
So once we've installed Git, we run git init first, which basically says, oh, okay, this is a new Git project.
Yes.
I want to be able to start tracking the files.
Yep.
And then once I start editing, then it can call git status, right? And then that will show me basically what I've made changes to.
Yeah, you can pretty much run git status at any point. You don't have to do make a change. You could just run git status. I run git status all the time to see if I made a change or not.
Okay.
At some point.
Sure. We got a couple. We got a couple messages in the chat. It says Irene, I gotta get used to pronouncing that. Kareem pronounced it perfectly, Irene, but I'm used to the English pronunciation too.
Okay.
I'll try to remember that. It's gonna take me a little bit of breaking that habit. And then Geek Nabil says we can use the CS50 IDE and not worry about the installation process. That's true, right?
That's a great point. Git is already pre-installed inside of the CS50 IDE, so if you want to get started right away without having to worry about installing this, you can just go to CS50.io and log into your workspace.
And then Bhavik Knight, I think, is maybe alluding to the same thing. He says, glad to be here, downloaded it, yet to install on Windows 10. He opened the IDE for now, so I think maybe he's saying he wasn't able to get it working on Windows 10 and he's using the CS50 IDE.
Yeah, that's great. If you want to follow along right now and you don't have it installed, feel free, of course, to log into your CS50 IDE and you should have Git installed there. Okay,
cool. So we've talked about installing it, we talked about git init, and then git status. All right, so now that we be able to track, I'm guessing it's...
Yeah, so the first thing that I wanted to explain, or before we dive deeper into this, is to understand the difference between these three main parts. Can we see all this?
I think we can switch to. I don't know if we have I can move us. I can move us.
I can also resize my window if that.
Let me go to the editor, and then just do a little bit of this.
Okay.
Just move us right off screen, and then move the chat box as well. Let's try that.
Okay, this sounds great. Okay, so this image is from the official Git documentation, and it shows us the difference between three areas or three states in which the files can be in. The first one of them on the left is the working directory, and this is pretty much our folder where we make changes to our file. There's a second place called the staging area, or the index as it's sometimes called, and this is where we say mark these changes, mark these changes to be committed in the next commit, or save these changes or mark them, hey, I'm going to save a snapshot of this when I do git commit next time. And then finally we have the Git repository, is where we have these changes actually saved. So it's important to understand the difference between these three areas. So once again, just quickly to recap, working directory is where we have our files, where we modify our files, where we work on our project. Staging area is where we mark changes. And Git repository is where our changes are saved.
Okay, so we stage the files, but they're not actually saved. Git's not saving them like permanently. It's kind of just like I'm putting down some files to potentially save later as being part of my .git folder.
Correct. Yes. And in this case, I think one of the things that this allows us to do is make a whole bunch of changes and only save actually some of them in history. And I forgot to mention this, but Git keeps track of changes by means of taking snapshots of your project every time you do git commit, as we will see soon. So in this case, we could have a bunch of changes and only want to save some of them in history. In this case, we only stage these changes and then commit them. Yeah.
Okay. Cool. That makes sense.
All right.
Do you want me to move us back into the view?
Let's actually look at this first as well,
sure thing.
Because it's also important to understand some of this. If you might have noticed earlier when I did git status, Git said that, hey, I have these untracked files right here. So
those are files that were in the folder already, and then you called git init, and then it was able to recognize, oh, there's some files in there that I'm not actually tracking yet.
Correct. So these are files that exist in your Git repository or project. We're just going to start calling it repository now. That Git knows they're there, but it doesn't track them.
So it scans the folder sort of and says, oh, I don't actually have a reference to these files yet.
Right.
But in case you want to add them or you want to stage them,
correct,
like here they are.
That's exactly right.
Okay.
The second state in which a file can be in is unmodified, and in this case, it's not showing in the Git status because this is a file that we pretty much didn't touch. Like it's the copy that we have is exactly the same as the one in the repository.
Right, but that's a file that we previously were tracking, and it's saying, oh, you haven't changed this since the last time you last time you basically did whatever, committed it or whatnot.
That's true.
Okay.
And third, we have modified, and these are files that are like we made some changes to them, so modified files. We're going to see some of these. And lastly, we have staged, and these are the files that are in the index area or the staging area in this case.
Okay, that makes sense.
So it's just thought it will be useful to get this visualization in mind before we start working with things. So in this case, I have these untracked files, or specifically, I have an untracked file in an untracked folder in this case. The first thing that I want to do before committing them or saving them in the history is add them to the staging area.
Bavignite's got a question.
Yeah.
Bavignite says, staged is in our terminal, right?
So Git takes care of all of this. Like, you don't have to work on a terminal to have these three areas. Like, this is how Git works. So this is not related to what environment you're using to access Git.
Okay.
If that answers the question.
That makes sense. I'm going to bring us back into the into the view here.
Okay, there we are.
Awesome.
Okay. Perfect. So the first thing that I want to do is presumably run git add. But the problem is, like, Git seems to be complaining, like, nothing specified, nothing added. So it seems that I need to specify something. And I could definitely do git add application of Pi, and then, or maybe add templates, or do git add application of Pi on its own line, and then git add templates on its own line. But the good thing is that there's actually a command line option that allows me to add everything that's changed or untracked in this case. And I only know this by looking at the documentation. If you do git help add, whoops, actually, man git add, is it? Okay, so we don't have man installed, so let me show you on my own terminal. So if you do git help add, assuming you installed all of Git, you're gonna see this manual page. And it lists how, like, what the command does and like how to use it with the different options, how these options change the behavior of this command. In this case, I'm really looking to add all the files in this case, and if I keep searching, I can find here, we can find -a or --all in this case. So it seems to me that if we do git add -all, that should add everything. We see nothing, which is good. Previously we saw a complaint. So if you do git status again, now we see these files in green.
So now they've gone from the untracked, and now they're in the
Staging area.
They're not part of the unmodified because they're new files, but they are being staged.
Okay, so now they've gone from the working directory, to be specific, to the staging area.
They basically skipped a couple of those steps in the diagram, effectively.
So we're referring to the first diagram here in this case. So right now,
okay.
like, they were in the working directory in this case. Actually, I'm not really sure if they would be considered part of the working directory if they are initially untracked. But yes, okay, let's say they are in the working directory. And once we git add them, they move to the staging area in this case.
Sure. Yeah, I guess I was looking more to that second diagram.
Yeah, so the second diagram is more about this thing on the left here. So this says new file. Previously it said that this file is like untracked, or actually it probably showed it up here. So these are changes to be committed in the staging area. And it's saying that, hey, all these are new files. We're gonna see when it's gonna show modified. It's probably gonna show it like here on the left instead of new file.
So we can use git add and then the name of the file that we want to add, and this is a file that we aren't tracking yet. Or we can do git add --all, and it'll just add everything that's untracked in the current directory.
Yes, but I believe everything that's untracked or modified in your working directory.
Okay.
It's gonna add it.
Gotcha.
But again, you can always add specific things. So if you just want to add certain untracked files or certain modified files only, you can just do that. In this case, we just want to add everything, so we did that. And the next thing is, do you recall what the next step is?
Well, I know that when I have a file that I've just added, and I want to get it ready to push to GitHub, and I want to stage it, I usually use git commit, the function git commit.
That's exactly right. So now I want to tell Git, hey Git, save this as a snapshot in my repository, or as a commit in my repository.
Sure, so like taking a picture of all the files in their current state that you can then like maybe recollect or pull back from GitHub or from someone else's computer in the future?
Yeah, in this case, we don't really have any connection with GitHub yet, but yes, this saves, this is actually a perfect analogy, it saves a picture of the state of your project or repository right now that we can use later in any number of ways.
Geek USA says hi. Hi Geek USA, good to have you with us.
Yep. Okay, so git commit, and again, Git seems to be complaining about lots of stuff here, and particularly it tries to tell me, hey, you want to set your email and name and all of these information. So the thing is here that Git doesn't only keep track of like files and what changed and what not. Git also keeps track of information about who changed these files, which is, you can imagine this is also useful in case we're working on a big project, we are 10 or maybe 100 developers working on the same project, and you want to check like which developer like changed this particular part or added this particular part.
Who to blame for a broken piece of source code?
There is actually a git blame command that does this. Yeah, so who to blame, like if you just want to maybe email them, ask them about something, or insult them maybe, I don't know, in case you don't like the changes, please don't do that.
Nabil has a question, if maybe you want to read it off there.
Sure. If you have lots of files, for example, 100 files, and we want to add only 98 of them, in this case, git adds will add all the files. This isn't what we want. And adding every file separately with git add file name with this, it will be hard to do git file name 100 times. This is actually a great point. I don't really see a use case where you'd have like 100 files, 98 of them, you want to, in the same directory, 98 of them you want to add, and 2 you don't want to add. But the good thing is that you can actually, like, if you don't want to group these files under one directory and add this as a directory, one thing you can do is use some of bash features, which is the shell that we're using here, to actually specify certain patterns for files to add. So for example, I could tell Git, hey Git adds all the files that start with the prefix foo, for example. So
like foo star.
Yeah, exactly. Git add foo star, or you can really play with this logic and like customize it however you want to fit your use case.
So it's kind of on the developer at that point to be smart about making sure all the files start with like some common identifier or have a common file type, suffix.
That's exactly right. Yeah, I personally imagine it's going to be a pain to have to manually add like 100 files, of course. So maybe there's some criteria that you could just match all these files with, and it should be pretty easy to use this criteria to select these or to add these to the staging area.
Makes sense. Cool. And
Yeah.
Bavik has a question as well. Can I get some link of the project for testing? Do you have this project as a public repo by chance?
So we haven't pushed this to GitHub yet. We're going to push it at a later point, and I am probably going to also zip all the source code that we're using here and maybe upload it if you want. The point is, I don't really, like, you can work on any project you want. I don't really see anything necessary about using this specific project because I'm literally starting from scratch.
Cool, makes sense. Yeah, definitely follow along using the same commands as Kareem does, and you can even just put in your own, I think, just dummy files, right?
Yeah.
More or less work. So.
Yeah, exactly. But these are a little tweaked versions from the FrushIM's example from David's lecture, which I believe you can find on Zidane, cs50.net/20, whoops, not 2014, 2018 actually, full lectures 7.
You're getting partially cut off too. I don't know if you want to maybe come a little bit more this way. Just
Search
so
7, I think.
Just move your chair a little bit.
Oh, sorry.
No, you're good.
Okay, let me
There we go.
do this. Okay, so if you're curious about using some of these, like, there are these, and there are many other source code examples from lectures that you could download and use. This is part of what I'm using, or I'm using part of this actually. Okay,
Cool.
so we missed the
All
component
right, we were
earlier.
going to talk about git commit because
Yep.
now we have the untracked files, and we've added them with git add --all.
Yep.
And so the next stage, like you said, we're going to take a snapshot of the basically the working or the directory as it is right now.
Correct. We need to save the changes that we have into the repository in this case. But before we do that, we need to tell Git who we are. And in this case specifically, we should at least configure the email, it seems, and the name. So I'm going to do exactly that, and notice that Git is really helpful in giving me the exact commands that I need to use, so I can just copy these. So in this case, I'm just going to specify my email. Zidane, CS50, Harvard edu. Okay, perfect. And then, actually no, the other one, get config-global user.name. And notice you have to specify quotes if your name has special characters, just to make sure that it gets it right. So I just configured my email, I just configured my name. It's a little bit ugly because it splits on 2 different lines, but that's okay. And now, maybe I should try to do git commit again. And this is actually a text editor that I see open right now. It's Vim, if you're familiar. And Git is basically telling me, hey, what did you change? I need a description of the changes that you just made.
Sure. Gotta
And
be
this
able
is
to tell which snapshot is which. You know, if you're doing 50 a day.
yeah, exactly. You need to be able to, like, if you're looking at the commit history or the log, as we will soon see, like you're going to see a bunch of different commits, and it will be really useful to see, like, just by a quick look, what this commit did.
Sure, that makes sense.
In this case, I'm just going to, you should ideally be more descriptive, but I'm just going to say first commit. This is my first commit, and save. This is how you save in Vim, if you're curious, and exit. And now it tells me that, hey, I added 5 files, and all these different information about the modes for the files. We don't really have to go into these details right now. This is permissions of the files and so on. But it seems to have worked.
Looks like Bob Ignite has a question for you as well.
Sure. So what's the difference between add and commit? That's a great question. Add marks the changes that we have as changes that we want to commit when we do git commit next, if that makes sense. So add, like, the staging area is an intermediate step where we mark all the things that we want to save in history permanently before actually saving them in history, if that makes sense.
Cool, and then commit actually is like taking the picture of the directory and saving that so that we can then look at it later and sort of figure out what our repo looked like in the past and then revert back, right?
Yes, that's exactly what commit does. Commit looks at the stage changes, in this case, that we added by git add, and then takes all of them and saves them permanently in history.
Cool, makes sense.
Okay, do you have more questions? Okay. Perfect. All right. What do we want to do next?
Yeah, so we've committed everything, right?
Yep.
So now everything is, I guess, saved. So if we did it again, we'd have 2 snapshots. If we did it again, we'd have 3 snapshots.
Right.
I guess then it'd be a matter of, demonstrating either maybe how we go back to a snapshot or maybe how we publish it.
So for that, I think we need more than one snapshot or more than one commit to be able to go back to the previous commit. Right now, we just have one of them.
Sure.
So this is going to be a little bit tricky because essentially we tell Git, in this case, hey, forget everything. We didn't do anything. But we will actually demonstrate this later. One thing you might be interested in, though, is looking actually at the commit history so far.
Sure, yes.
So one way we can do this is using the git log command, in this case.
Right, okay.
And it shows this long, weird, yellow.
Hide the chat there just for a second so you can see the full thing. Okay.
All right. So we see this first line, this weird long string. And this is actually, this is actually an identifier for this commit. It's a hash generated using an algorithm, I think it's SHA-1, that actually uniquely identifies this commit. And we can actually use this hash to refer to the commit later.
I see it has your author information that you put in that git config command as well.
Exactly, yes. So it lists me as the author. It says this is my email. It also lists the date or the time and the time in which these changes happened, and of course the commit message in the end.
Okay, yeah, that seems super useful.
Yeah, so let's actually make some changes. So I have all of this right now, so let me actually, I don't know, I have changes that I pulled from lecture from before, so let me actually copy from source, froshinds1, I believe, everything here into this directory. So you can simulate this by essentially opening your file and making actual changes. In this case, I actually copied files that are different into my current directory. Specifically, now I think I didn't show you what application.py was initially. So we should probably take a look at this. And we're going to learn about this command later, but let's git clean here, git checkouts, application.py.
So what does git clean do?
This is discard any untracked files in my working area. We're going to explain this later. I just want to show you first what application.py looked like in our previous commit. So if we do git log again, this is the only commit that we have. Okay. And if you do git status, nothing's changed. Mm-hmm. So I'm opening application.py now, and here's what I have. And this is not really about code specifics, so we can really not really care much about this. But here's a file.
Just a super simple Flask app.
Yeah, super simple Flask apps that expects to get parameter, name and dorm in this case, and renders a template called failure.html if you don't provide any of these, or renders success instead. So again, not really interesting in this case. I'm going to copy updated application.py from froshims1. And again, you can do this, you don't have to copy stuff. You can do this directly in application.py in this case. Actually, let's copy everything in this directory in here. If I do git status now it shows that application.py is modified.
Okay.
And it shows a new untracked file, templates/register.html in this case. So one question that might come to mind here is, what changed about application.py? And the way we can do this is literally doing git diff application.py. And you can see this nice diff view provided by Git, coloring the things that the lines that were removed in red and putting a minus in front of them, and the lines that were added in green and putting a plus in front of them. In this case, I specifically changed the first line, the importing stuff, added this array, and I'm just scrolling down, added a few variables, and added a function.
So this was froshims 0 before, and then you copied froshims 1 and overwrote it, and now it's showing you the changes?
Yep, this might be a little bit confusing. I could have done exactly the same thing by actually opening application.py in this directory and making the changes to it. I'm probably going to do this next time. But in the meantime, we just changed the application.py, and Git showed me that application.py was modified, and when I did git diff application.py, it showed me what actually changed.
Okay, so yeah, the green lines are something that you added to the file,
Yep.
and then red ones are ones that you deleted from the file, or changed in that file, right?
Correct.
Okay, makes sense. It's like a nice visual sort of indicator of the changes that you've made if you're not exactly sure and you're only at the command line, and there's other tools, like GitHub will show you differently, right?
Correct. It's actually going to show a pretty similar view to this. I'm not really sure if you can show the diff side by side here. GitHub does allow you to show the diff side by side. There might be a way to do it using Git. I need to look at the documentation for this. But this is what you see when you do git diff.
And like some text editors even now, like VS Code and Atom will show you like embedded like GitHub views so you can see which files are changed, or usually they'll have change being like blue, and then they'll have deleted lines being red and new lines being green. So even text editors now have like built-in Git integration, which is really cool.
Yeah, I'm sure like text editors and IDEs, if they don't even have this as a built-in feature, I'm sure there's some extension or plugin that adds this feature. But in case you're not using a text editor that supports this, or you just want to work directly from the command line, here's how you do it.
Awesome, looks really cool.
Okay, so notice if we do git diff as well, it still shows us the changes only in application.py and not anything about templates register.html, which, if you recall, was actually like already an untracked file, and this is because it's literally untracked.
Right,
It doesn't know anything about it yet.
It doesn't have a prior history snapshot or whatever to compare the new one to tell you what's changed, right?
Correct, exactly. So again, the way we add these, like suppose we're ready now, and we'd like to commit all these changes to, or save them in our repository, the way we do this is running git add --l or in short -a. If I do git status again, it shows me that both files are staged. One of them is actually modified and one of them is a new file.
Yeah, so you can it'll tell you actually whether it's you haven't tracked it before at all. So
Correct.
you can say, oh, this is a file that changed, and this is a completely new file.
Correct.
So it's kind of nice. It kind of gives you that feedback there.
The good thing though is when we did git diff earlier, it actually compared the changes in our working directory to the changes that are saved in a repository, if you remember. When we saw this nice diff screen, it was actually comparing the files, the application.py that was saved in the repository against mine in the working directory.
Right, yeah, because it had that snapshot from before, and it saves that in the .git folder, right?
Yes. Now, if you do git diff it's not going to show you anything.
Interesting.
And this might be a little bit confusing, but this is because by default, git diff compares the changes in your working directory to the changes in the staging area or to the repository if there are no changes in the staging area.
Okay.
I think so. The way to compare the changes in the staging area to the repository, if you want, is by running git diff -- cached or staged.
Okay, that makes sense.
And also, I know this only by looking at the documentation. There's no way that I could have known this.
But since we didn't commit those files, there was no history, so they had no diff information to give us, basically, the files that we have now.
Yes. Okay, so in this case, I'm comparing the changes that are marked as saved in my staging area, or marked as to be committed in my staging area, to the changes that are, to actually the snapshot that's in the repository, if that makes sense.
Looks like Babbitt has another question as well.
Sure, let's take that first.
Okay.
So we add a file, make changes, and then commit. Slightly inaccurate, we make changes, add the file, and then commit. And it gets updated on GitHub. We haven't gotten yet to the GitHub point, but we're going to discuss this pretty soon. But I hope I made these 2 points clearer.
And GitHub is kind of like it doesn't have to necessarily go on GitHub. There's other places, right? Other websites that Git can push to?
Yeah, so I mentioned in the beginning that Git is a distributed version control system. And what distributed really means is that if you're more than one developer working on a particular project, then each of you is going to have a copy of the project and its history in whole. Previously, if you're familiar with other version control systems like Apache's Subversion, SVM for short, that was actually a centralized version control system, which means there was actually one copy on the server, and all these developers interacting with this copy are just maintaining references to the files and changes in this copy. And you can imagine this, one side of this is that if you're offline, then you're disconnected. There's no way you can commit changes, right? In case of Git, that's not the case. Git is distributed, so each one of us is going to have a copy of the whole project plus the history, so we can just work completely offline without needing GitHub or any other service.
And so a company using Subversion, if their server goes down, everybody's kind of screwed, right?
Yeah, I'm not sure many companies use Subversion right now, but yes, that was I think one downside of. I'm not an expert in Subversion myself. I've just used it very, very briefly.
Right, so I guess the principle is if you and I have the same project and we both have a copy of it, if your laptop gets wiped, you can at least get the copy off of my computer because I've maintained all the references through basically all the snapshots that have ever taken place.
Correct.
Up till the point that I cloned the copy on my computer.
Correct.
I copied it onto my computer.
Or even better, if we have a third-party service like GitHub or Bitbucket or any number of other services, I can just fetch a copy from this service immediately, as we'll see.
And even if GitHub goes down, because thousands or even millions of people have cloned some big projects or any project, right? They can just re-upload it to GitHub. Any one person can upload that project at the point that they cloned it and kind of just refresh them.
Well, if GitHub goes down and lost data, that's a bigger issue at this point. But yes, essentially yes,
it's kind of a fail-safe, I guess.
You just want to make me go to you to get the copy anyway.
Yeah.
But sure, I can do that. All right, do we have other questions?
I'll bring the chat back up because I realize it's not enough for a little bit.
Do you want me to get this closer to you, maybe?
No, it's fine. I can read it pretty well from there. All right. Here we go. We got a question from Dragavaradero Dagavaradero. GitHub is equal to Bitbucket. He put double equals, not triple equals. For in JavaScript, I believe that's type equivalence, the type equivalence operator. So equal but not quite equal.
I guess that's true-ish. I mean, GitHub might have features that Bitbucket doesn't have, and the opposite. So it's not necessarily that they are all equivalent. You just want to do a little bit of research and see which one would be best for you.
Ignite. We can. So can we see the changes other developers are making when they make changes to the same file?
We will get to that. Yes.
Awesome.
But good point. Okay, so now. Once again, we ran git diff -- cached. This could also, I believe, be -- staged. Yep. it's going to show me the same thing. And it's going to compare the changes that I have in my staging area right now to the repository. And notice now that it's actually also listing information about templates/registered. Previously, it didn't show anything when you just did git diff and it was in the working directory. And this is because now it is in the staging area. So it's a new file added to the staging area. And it shows like what this new file adds to the repository in this case.
Nice. And what command did you run to put it in the staging area again?
Git add.
Okay, right.
Dash
Just called
O,
git add. Okay.
yeah, or dash A. Yep.
Cool, cool. Metal Eagle, I know plenty about Git, however, I want to get better at two things, solving merge conflicts and knowing how to remove a commit for a certain file that you have accidentally committed to be pushed to your repo. How can I do that?
These are two great questions. We're going to answer them pretty soon when we get to branches and merging. But long story short, the way you resolve merge conflicts usually is by literally opening the file that has a merge conflict and removing some symbols from it and removing the snippets that you don't want in it. And just to clarify a little bit, a merge conflict happens when you and I are working on the same file, potentially, and we modify the same line or same number or same lines in two different commits, and then we try to merge these changes back together. The problem is, when you merge these changes, Git doesn't know, do you need your changes or my changes?
Right.
And so we have to solve or resolve these manually.
Rather than flipping a coin.
Exactly, yes. Yes, so we're going to get to that. Hopefully we remember these two questions to answer them when we get to Git merging. Now that I have these, I can commit them. And previously I just did git commit and it opened the text editor for me. The good thing is that you can just pass a commit message on the command line by specifying -m and then the commit message. So in this case, I added a students list. So this is an example of a commit message. It should be short and descriptive. I believe shouldn't be theoretically, I think it can be longer than that, but I think the good practice is that it shouldn't be longer than 50-ish character. But if you find yourself want to add more details, then you can just do git commit, get back to the text editor view, add a short description on the first line, and then a couple of lines later, you can just add a more detailed description if that's something that you want. So in this case, I'm just going to commit the changes. Git is going to tell me what changed briefly. So just to verify, I'm going to do git log again, and now I see these two commits.
Nice, and it shows the most recent one, it looks like, on top. So at a glance, you can see immediately, what the most recent commit was.
Yeah.
Bavik says, all we're doing is staying between our PC and GitHub as in the staging area?
Not quite. So still we have no connection to GitHub whatsoever. All these three areas are areas that are used by Git completely locally when you're working within your project. It just uses it to separate between the different things that we talked about. So nothing that has to do with GitHub at this point yet.
Cool.
Okay. All right, so we see our Git log. We verified that our latest commit got added. One thing you might be wondering at this point, hey, what if I made a stupid change to a file? I just added a foo to application of pi here. Should have probably done this using text editor. But I just added a stupid line here.
We'll have to have you do a Linux terminal command tutorial as well for people.
We probably should. So if you do git status, we can see that application of pi changed, and then if you do git diff, or git diff application of pi in this case, it's just going to show me, hey, this line got added, and here's the line that got added. But suppose I don't want to do this. Suppose I want to discard this change. The command one way I can do this is using git checkout. So I can do git checkout, and then dash, and then the file name, in this case, application of pi, right? And then I hit enter. If I do git status again, nothing changed. my working directory matches what's in the repository right now. And if I open the file again, scroll back to the bottom, I don't see my line anymore.
So git checkout just kind of erases any changes that you've staged?
Correct, yes. It discards the changes in these cases.
Okay, cool, that makes sense. Looks like Andre from Facebook is in the chat if you want to read his question.
Sure. Hi Kareem, great to see you. Thank you. Great to see you here too. Is there a way to avoid merge conflict symbols being entered into a file that's been automatically generated? Removing merge conflicts from auto-generated XML can be quite tedious. Is there a way around this? I'm not really sure if there's a way to remove these symbols or even to change them. What I do know though is that I know there are merge tools that exist that you could use that would help make the merging process easier for you. And I also know that there are certain command line options that you could use to say, like to tell Git, hey Git, use the changes from X or use the changes from Y and don't care about the other changes if a merge conflict happens.
Makes sense.
So I hope that answered your question, but I should probably look into this more.
Craxy has a question or a statement. Git checkout can be dangerous, meaning it will erase all your work and cannot be recovered.
That's true. So you want to be careful when using git checkout. That's a good point, actually. Unless you preserve the history in some other way. For example, if your text editor preserves history, then they could be recoverable in this case, but otherwise you want to be careful when using this because you could literally lose the work that you did. And this is why, actually, this is a good point. This is why committing changes frequently is a good idea, right? Because you can just pretty easily revert back to the previous version.
Makes sense.
Okay, what else do we have here? So we have a bunch of things, actually. You said this is going to take longer, and it seems to be taking longer. But what if I change my mind? Like, what if I want to do something like, hey, update the commit message of the last commit, in this case. And so one way to do this is using git commit --amend-m, and again, I know this by looking at the documentation, and then mention the new commit message. New commit message. Of course, it should be more descriptive than this.
I actually didn't know that was a thing. This is the first brand new thing that I've seen so far. Git commit amend.
So if you do git log, in this case, you can see that the new message is now no new commit message instead of added students.
Okay, that's awesome. I'm gonna actually start using that if I screw up.
Another thing, actually, take a look at the commit SHA in this case. I think it's going to change if you do this. Like every time we do commit, like right now it starts with fa14a blah blah blah. So if we do git commit --amend-m, let's go back to our original commit message. Added students list. Git log.
Oh, you're right. It did. Okay.
It changed. So Git actually, this is actually one of the great features about Git is that it really has a great integrity, or ensures that the data has integrity in this case. So it seems to be that the commit message is actually part of the input or part of the data that's hashed when calculating or computing this.
So is it deterministic, such that if you were to do it again, the git amend with the other message you just had, would it be the FA14 or whatever?
I thought the time was taken into account too, so that.
Oh, okay, that makes sense.
But let's actually double check this. This is a good point. What commit message? Is that what you did? I think it started with F last time. Nope.
Yeah, FA14. Yeah. Okay, yeah, that makes sense. It would make sense for them to put the time in there, I guess, because if it was deterministic, people could all write the same file.
Yep.
If time weren't taken into consideration, and then get the same commit.
Yeah. So what I meant by integrity, just to briefly explain, is that if we're both on the same commit that has the same unique identifier, then we exactly have the same state in our project. That's what I meant.
Okay.
So yeah, this is one thing you could do. Another thing you could do is temporarily or permanently revert back to a previous snapshot. And I think you alluded or asked about this earlier. And one way to do this is using the git reset command. Before using git reset, I think we should have explained something about this weird blue or cyan head on the top right. So, and master as well. So these are kind of pointers or references if you're familiar with these terms. And head is just kind of a pointer that always points to the commit that I'm on right now. Master in this case happens to be the same thing as head, but in this case, head and masters are both two references that point to the topmost commit in this case, which is D615 blah blah.
Okay.
Does that make sense?
Is head always the topmost commit?
Head is always, not the topmost commit, head is always where you are in the repository.
Oh, okay, I see.
So you could be standing on, like you could have, we're going to talk about Git branches later, but imagine we have 10 commits. We could, stop on the third one or change our state to be the same as the third commit, as it was in the third commit. In this case, head is going to be pointing to this commit.
Okay.
Branches, on the other hand, are always pointing to the tip of this branch. So master, in this case, we have a branch called master, and the reference master is always pointing to the top commit in the branch master.
Okay, that makes sense. We have a couple of questions there in the chat too.
Yeah.
The Bavik Knight and Geek and Bill.
How can we change the second commit message? This is actually a little bit more tricky. And the reason this is more tricky is because of the same point, the integrity of data. So you can't really change the contents of a commit in the middle without actually changing all history that follows that. Because I think also part of the information of the commit, like the commit char or whatever, is also taken into account when calculating or computing this hash.
So it'd have to propagate to all the commits after that one, basically?
Correct. The good news is, though, that there's actually a relatively easy way to do this. We're not really going to talk a little bit about git rebase, but essentially you could do git rebase -i, and of course it's not working right now. I think it's going to be head, is it? Nope, not head. Let's see, git log. I think we need to get rebase on the first commit, which is the SHA starts with 6f8cd something something. So I think we need to do get rebase -i 6f8d, right?
CD, I think.
CD.
6f8cd, yeah.
8cd. Okay, and then in this case, it shows us only the commit after this in this case. And notice here, there's a bunch of comments about what we can do with this commit. So in this case, I want to change the commit message of this, right? So I need to change pick to a reward, or just R for short, if I want. So just get rid of this, change it to R, save. And what do you want to change the commit message to in this case? So
Bavik Knight. Or no, who was it? Geek and Bill. That was the person that said it.
Like this,
Yeah.
save, git log. Notice that the commit SHA, this is not really, like, it's not gonna be really obvious in this case because we just have two commits, but in this case, the commit message did change. Can we change the commit message of the very first commit? That's interesting. If I do this, is that gonna work? No. Okay, I'll need to look this up, but yeah, I don't know how to rebase on or change the commit message of the first commit without actually doing something more fancy than this.
Deceptively complex thing to do.
It is, yeah. It's really one of the things that are relatively annoying, but it's good that we have at least a way to do this.
Yeah. Bavik Knight had another question. It says, is there any other way without losing changes made but see older version? I think he was talking about git checkout.
So yes. So you want to see the older versions in the repository while you have changes? Is that what you're talking about? I don't know.
I think that's what he's talking about. Yeah. I guess like keeping changes that you currently have, but seeing the file as it used to be.
That's a good point. I think you can do git show. So if you do git log, in this case, suppose we want to show what changed in the first commit. Maybe you can do git show 6f8cd, and this shows you the contents of the application.py and the other file. Maybe you can do git show application.py. Is that possible? Yep.
That's pretty cool.
So you can just see the changes. I think you can also check them out if you want to a different file altogether. And the way to do this would be git checkout let's see, what was the commit SHA? So instead of this, that would be git checkout, the commit hash, and then the file name into, let's see, old.py. That's wrong, of course. Maybe I'm missing something. Okay, but there's a way to check out the file. We're going to have to look this up. 6F8CD. Yep, there you go. Okay, so the reference that you want should be before the dash dash in this case. So now if I do cat old.py, I don't see anything because that was empty. I guess I did something wrong. Anyway, we're going to look at this later. So yeah, this is not the way to do it, apparently. But I'm pretty sure there's a way to concatenate or copy the contents of the file in a previous commit.
Powerhouse of the cell, shout out to Nick Wong, says git stash.
Git stash, that's actually a good point. Git stash actually temporarily discards the changes in your working directory, yes. So I guess we could have used actually git stash. That's really a good point. Thanks for bringing that up. So suppose we do the same stupid thing, echoing foo to application of pi. Now if I tail application of pi in this case, I see foo in the end. If I do get status, I see that this changed. If I do get stash, notice that this is also, I think, going to discard, or not discard, temporarily save the change, even in the staging area, to some fourth area that we didn't talk about, the stash in this case. So if you do get stash, it tells us that, hey, I saved these changes temporarily. If I do get status again, nothing's here. So presumably, if you open application of pi now, it actually matches what's in the repository. And the way to get these changes back is using get stash pop. Oops, pop. Like this. I do get status. Now I see application of pi with the changes that I made.
That's pretty cool. That's like a nice little like a sketch pad to work with, I guess.
Yeah, that's a good question. All right, that's a great point. There are other ways to revert back to a previous point in history, in this case, using the git reset command. And I think there are three distinct ways to use git reset. One of them says, hey, I don't care about anything that I have right now in the repository, just reset the state of my repository to a particular commit. And this will be git reset -- hard, the reference to this commit.
Okay.
Right? So the SHA, for example, or whatever that we want.
And this is basically like reviving that old snapshot and making the directory reflect that snapshot.
Exactly. It's forgetting about any changes that you have right now in the repository and force resetting the state to the same state as it was.
And just like checkout, this will erase all current changes, right?
This will erase all current changes, yes.
Okay.
The good thing, though, is that it allows you to revert to a completely different commit. Like all the files, all the folder structure is going to be the same as in this commit. While with checkout, I guess you can just check out certain files from that commit. There should be a way to check out everything, but I think it's going to be a little bit more complicated to use than using git reset by itself. So I referred to head earlier, and the reason I did that is that head is actually, right now, if I do git log, head is actually the same as AA79 whatever, which is the SHA or the hash of the first commit, or not the first, the top commit rather, in this case. And the cool thing about this is that we can actually refer to commits without necessarily hard-coding their SHA or hashes using simple arithmetic with head. So for example, if you want to reset back to the commit that's the parent of the current commit, I could do git reset head caret like this. And notice that, oops, now if we look at git status, it shows that application apply is modified, templates registers untracked, which was the case when we first added these files. If I look at git log right now, I see that the commit that I had, the second commit, disappeared, and now head is 6F8CD ...
Makes sense.
right? So this is one way. I don't want you to get lost, but we mentioned that there are 3 ways you can get reset. You can force reset everything. You can just do get reset without any flags in this case, so not hard, not soft. If you're gonna force change back, you can do get hard. If you want to change back but maintain the changes, like in this case, you can just do get reset. Or if you want to go back but maintain the changes in the staging area, that's going to be get reset soft.
Okay.
So I guess we could demonstrate each of these. There's another cool command that, another cool feature is that when you do that, Git actually doesn't permanently forget about the commit. You could do git ref log and see where head was before, and apparently the commit that we lost, which was AA7 something something, we could just check this out now. So git check out AA79 something something, and of course we have changes. Let's stash these for now. So let's do this again. Whoops. Oh, okay. Git clean D. Discard any of these changes. Let's try this one more time. And now I'm on detached head. So I can, if I do git log now, I can like see my commit back.
Okay.
In this case. So I haven't lost it permanently in this case. I believe after a while, Git might garbage collect this. I'm not quite sure. I know for sure that's old commits on GitHub, which we'll get to in a while, are actually like, or not old commit, like abandoned commit are erased after a while. So in this case, we can get to our own commit. So when we did get reset to the parent commit, what happened is that our changes were maintained from that commit, AA7 something something, in our working directory. If I do get reset, same command, but add dash soft to it, parent of head, I do get status again. Now our changes are still maintained, but instead they're in the staging area.
Okay.
Right? So you can imagine this is useful because if you change the same files in your working directory right now, this is not going to override these changes.
Right.
If that makes sense. And finally, let's get ref log. Let's get stash again for now. We don't have anything. So let's get checkout, get ref log. Let's actually do get ref log here. And get checkout AA7D9. And then again, we have the same commit. Now, if you do get reset dash hard to head, the parent commit of head, in this case, it's actually going to reset this, force reset it actually, do get stats again, we don't have any changes. So this is going to force the state of your repository to be in the same state of this commit.
And this is where we are with like fresh IAM 0, right, when we committed it? So it's basically going to be at the very beginning?
Correct, yeah. This is, yeah, you can always check where hit is by using git log. And in this case, we're like on the first commit.
Nice. There's a lot of different ways to reset the
Yeah.
branch. Reset head, I should say.
Yeah, do you have any questions so far? I imagine this is quite a mouthful.
We haven't gotten any messages in the chat yet, but if anybody does have any questions, definitely toss them in the chat there. We'll take a look at it. We'll be monitoring in real time. But if anybody doesn't have any questions, I guess we can move on to the next topic.
All right. Let's see. What do we have here? We talked about git stash. We talked about checkouts. Suppose you would like to, first of all, I think we lost the commit here. Are we on master? Okay, now we're on master. Can we merge the commit that we lost again? Because in this case, we lost it from master. Can we do this? Okay, look, what was the commits again? AA7D. Can we do git merge AA7D? Okay, cool. Okay, now we got our commit back. So now master matches exactly the same state that we left it on in before doing all of this crazy stuff. Okay, so one thing you might be interested in doing is actually removing one file, and there are more than one way to do this. The easiest, of course, is to actually remove this file. So suppose I want to remove application.py. If I do git status again, Git is going to tell me, hey, this file is deleted. And you can literally like add this to the staging area like we did with any other change, application pi, git status, same thing, and then we can commit this like last time. The other way, and I'm gonna stash these for now, okay? So the other, now if I check again, I have my application of pi. The other way I can do this is using git rm, so git rm application of pi, and I believe this is gonna stage it automatically for me. So it doesn't require 2 steps in this case.
Nice.
Okay.
Looks like Geek Nabil has a question for you as well.
Sure. Let's take that one. Use all these commands in life. Okay. Do you, Kareem, use all these commands in your everyday life, or is there some basic commands you use? Another question, how does submit 50 work? Okay, so these are 2 questions. One of them is way, way beyond the scope of this stream, which is how submit 50 works. But I'm gonna try to explain the basic details of how that works.
We could also do maybe a separate stream someday where we go into Submit 50 in a lot more detail and have time. But maybe if you want to give them a couple sentences, I guess that might be.
Yeah, certainly. For the first question, do I use all these commands? You want to say yes, I do use all these commands and more. But the catch is, I didn't really sit at some point and read like the whole Git documentation. I just learned things as I went. So if I want to add something to the staging area, I just Googled that, how to add this. Right. And I just found git add, git commit, git reset, git riflog, and all of these.
Stack
so
Overflow.
Exactly, yeah. So I don't really, like, you should probably, if you find yourself trying to memorize these, you're probably doing something wrong. I think what you should do is just learn about what's out there, if you can get a basic idea, and then as you go, as you need to do something, just Google how to do this. And over time, if you use this again and again, you're actually gonna, like, I guess, develop a muscle memory and use these pretty easily. Yeah,
and certainly some commands are used a lot more often than other ones too.
Yeah, definitely, yeah. So
Elias also says, best Git tutorial he's ever seen, thanks.
Thank you so much, that's so sweet. Okay, so let's discard these now that we talked about git rm. Of course, we need to commit these changes if you want to actually save deleting this file. But it's also sometimes the case that I want to ignore some files. So suppose I need temporary files for credentials that I have, and I don't really want to save this in a repository. If I do git status now, it's going to show as untracked. The problem is, though, sometimes if I have even more changes and I try to add git add -all or git add -a, this file is going to get added to the staging area as well, and eventually going to be accidentally or not accidentally committed, which is not what I want. So one thing I can do is till git hey get, once you see this file or this folder or these particular files or folders, don't care about them, ignore them. And the way to do this is by creating a file called .gitignore in the current directory. And on each line in this file, you're going to specify a file name or a path or a pattern for these for Git to match against them and ignore. So in this case, I specifically want to ignore the credentials file. So what I can do is open this in a text editor. I can do this in one step. Ignore, and then say, hey, credentials. I want to ignore that file. Save and exit. If I do git status again, I don't see credentials, but I see .gitignore, which is okay. We want to keep track of .gitignore in our repository. Now I should probably just git add this, ignore, git status, verify what's in the staging area before committing, git commit -m, add it, or let's be more descriptive, ignore credentials. There you go.
Easy.
Yeah. So this is actually a feature that's frequently used of Git, and I think we should be ready to talk about branches unless we have questions first.
Cool. Awesome.
Okay. I don't see any. You?
Yeah, the stream takes about 10 seconds for them to hear it, so I'll monitor and I'll let you know if I see anybody ask any questions.
Makes sense. Do you have any questions in the meantime?
No, I'm excited to get to branching. Let's do it.
Okay. So branching is also one of the cool features of Git that allow you to work on different parts of the project pretty easily, or experiment with things pretty easily without really missing the state of your project or repository. It also makes it way easier to work with people when we get to GitHub later, because you can imagine each of us can have their own branch, whatever that means for now, and work separately, and then when we're ready, we just merge these changes back together.
So up to now, we've been working with the master branch, right?
Up to now, the default branch in this case is the master branch, and usually that's the main or the default branch in any Git repository. Of course, it doesn't have to be the case. It's just a convention. And usually this branch should be always in a good enough state, in this case, or a near perfect state.
Okay.
Like we don't want anything to be messed up on this branch, ideally. And so the way to, so just explain what a branch is in short. A branch is just a sequence of commits. So we have how many commits now? 3. So these 3 commits represent the master branch in this case, right? The way to list the branches that I have is using git branch. And right now it says you have one branch called master, and it's marking it in green and putting an asterisk in front of it saying that, hey, you're currently on this branch actually. So one way to create a new branch, suppose you want to add a feature or fix a bug or improve something, or you want to experiment, you can just create a new branch using git branch, same command, but then mention the branch name. So let's call this new feature. If I do git branch again, it's going to say, hey, I created a new branch for you. It's here, new feature, but you're still a master.
That's what the asterisk and the green text are representative of, I'm guessing?
Exactly. So the way to switch to this branch actually is git checkout, new feature. Now if I do git branch again, it says we're on new feature. Interestingly though, if I do git log, it shows the exact same thing, and shows on the top here that new feature is also pointing to the same commit. And this actually sort of supports the point that we talked about earlier, that Git does this efficiently. When you create a new branch, Git doesn't really copy everything that you have into separate place and just give you a branch to work with, but rather, if Git can refer to something from before, it's just going to use a reference to it.
Sure.
In this case, all 3 references, head, new feature, and master, are pointing to this specific commit.
Makes sense.
Okay. Now, you might find it a little bit boring to use 2 commands to create and switch to a branch. Usually when you want to create a branch, you want to switch to it immediately. So the way to do that is using git checkout actually, -b, flag that influences the behavior of git checkout in this case. Let's call this new feature 1. And now if I do git branch again, I actually created new feature 1, as you can see, and switched to it immediately.
Cool. So any features now that you write in new feature 1 aren't going to necessarily be in master or new feature, just new feature 1?
Correct. So let's actually verify this. So suppose I add a file called foo to my repository right now on new feature 1, the new feature 1 branch, right? So git add, git status. I see my new file, git commit, added foo, right? Status, everything's okay. If I do git log, notice here, it updated actually, and I can scroll through this, but notice here, it says like the head, both head and new feature 1 are referencing this commit, but master and new feature, which are the old branches, are referencing this commit.
Makes sense.
The cool thing is though is that if I do ls to list the files in my current directory, I see foo, but if I switch to master, I don't see foo.
Nice, okay.
So it's that easy, literally, to switch between different states of your project. So if you do git log again, I don't see new feature 1 at all here, and I only see my commits from earlier. Yeah, so this is also one of the really handy features of Git.
So Geek and Bill says, how can we think of branching, like a new path?
You can think of branches as a sequence of commits. We don't really need to get into the details of how these are exactly stored or how they're handled by Git for now. This is probably for an advanced Git tutorial. But for now, yes, you can think of a branch as simply a sequence of commits.
So like if I wanted to make a feature in our repo separately from you, I could make my own branch, and you could keep working on your own branch or on master,
Right.
and then later on we could sort of mix them together.
Correct. That's exactly right.
That makes sense. So that way you and I aren't working on the same exact branch.
Correct.
And then having merge conflicts.
Yeah, now if we have time, actually, we're going to demonstrate this pretty soon. Okay, so what else do we want to do? We showed creating branch, we showed switching to a branch. You might want to delete branch. So you were experimenting with something and you figure, hey, we don't need this branch anymore. We don't need any of these changes anymore. So let me list my branches one more time using get branch. Suppose I want to delete the new feature one branch in this case. So the way to do this is get branch dash dash delete and then the name of the branch, which is new feature one. But get prints an error in this case, saying the branch new feature was not fully merged. If you are sure you want to delete it, run get branch dash D, capital D, new feature one. And Git is trying to be protective and helpful here in this case because it knows that some of the commits that I made on new feature one don't really exist in any other branch yet. And it doesn't want me to lose any of these changes unnecessarily. So it prevents me from deleting this branch. If I do get branch again, all branches are still there. But it tells me if you're absolutely sure that you want to get rid of this branch, you can just do get branch dash capital D, new feature one. And now we deleted a branch. Just confirm. There you go.
Nice. Okay. Pretty easy.
Okay, so
Looks like Andre has a question there
Yeah.
in the chat. The larger text.
So, but branches are in fact stored locally on your machine, so you can switch between various branches of your project without actually having connection to your Git server? Yes, that's absolutely right. Optionally, all repository history are stored on your local file system, and you can switch between any of them anytime you want.
I guess it would come into play if you had your own branch on your computer and I had a branch on my computer, but we hadn't pushed it to GitHub yet. That's when we would have issues. Actually, we wouldn't be able to communicate our changes that way.
Correct.
We
Yes.
have to distribute them or centralize them somewhere so we could grab each other's information.
Yes, so my copy of the project and its history is completely separate from the copy that you have of the project and its history. So however, I can create however many branches on my local file system and you don't see them until I push to GitHub. Then if you sync your local copy, then you're going to see them.
Correct, yeah. Oh, good question from Andre.
Yeah. Okay. Or am I okay, that's a follow-up question. No, you're not getting it wrong. This is exactly right. Okay, what else do we want to do? We showed deleting a branch. Let's actually show merging changes in this case. So let's switch back to our new feature branch, right? And then let's copy files like we could do from Frosh IMs. That would be, let's see, 5 maybe? Let's actually simplify this. Let's actually do, touch a dummy file, in this case, create a dummy file, add it, commit it, status, where's the verify, commit it. Now, if I want to merge these, now recall that if I check out master again, switch back to master and ls the files, I don't see foo, my new file. Now, if I want to merge all the changes from my new feature branch, all I gotta do is git merge new feature while I'm on master.
It basically says, take whatever's in this branch and try to combine it with wherever I currently am, basically.
Correct. And in this case, git verifies that the changes were merged. And if I do git branch again, I'm still a master. If I do ls, I see foo now.
And there was no conflict because it was a separate file that didn't exist, right?
Yeah, this is actually a great idea. Let's demonstrate a merge conflict. So now let's get rid of, actually, by the way, let's demonstrate this first. If you do git branch dash dash delete, I think there's a shortcut for this. I don't remember it. Maybe dash lowercase d. New feature. Remember that previously it complained about this, having changes that were not merged yet. Now that we've merged these changes into another branch, if we try to do this, it's just gonna happily delete it.
Nice, okay.
So now I only have master, and I am on master. I could do git checkout dash b. Let's see, I don't know, fix a bug. Okay, now I should be on fix a bug or fix bug. Yes. Now suppose I do foo, I open foo and I add, new line here. Save my changes, git status, hey, foo was modified, git diff. Here's the line that was added. And git commit, what did I forget to do in this case? I should add it first to the staging area, right? So git add foo, or git add all in this case, because foo is actually all, essentially in this case. Git status, hey, foo is in the staging area, it's ready to be committed, git commit, -n, added new line, trying to be a little bit more descriptive here, git checkout master back. If I open foo, again, I don't see my line, because this line was added and committed on another branch.
Right.
But suppose you're working directly on master, which is not recommended. You should create your own branch. But just for the sake of saving time here, suppose Colton is working on master, and he opened foo, and he added my new line. Right?
Greedily, yeah.
So here's how foo looks like now. If you do git status, hey, foo was modified, git add foo, git status to verify that we have the things that are already be committed. Git commit -m, added Colton new line. Okay, now if you do git log, here's the commit, right? Suppose we try to merge now the changes from new feature. What do you expect is going to happen?
Probably bad things.
Probably bad things. You have good intuition, and not something we can merge.
That's a really bad
Interesting.
thing.
That's weird. That shouldn't have happened. Git branch, because we called our branch fix bug, not new feature. Okay.
Right.
So git merge, fix bug now. Still bad things happen. But now Git is telling me, hey, there's a conflict, and it's yelling at me that there is a conflict. There's a merge conflict in foo, automatic merge failed, so Git could merge this automatically, fix the conflict, and then commit. So again, Git is trying to be very helpful here. If we take a look at foo now, notice this weirdness. So there's a bunch of symbols and stuff. But we also see my line and your line in both.
I think this is what Andre also was alluding to before with
Yeah.
the XML.
Yes, yeah, maybe there is another format where you could output these changes. It's not really about, like, it's not like this should be, I think this should be easily machine parsable as well if you want to do this. But the point is not about the format in which like these merge conflicts are shown. It's more about Git is not sure which of these to take. If it knew, it would take these like pretty easily.
Yeah.
But Git doesn't know in this case. So in this case, me as a human, I as a human, I have to fix this merge conflict manually. And I can do this by favoring my line or Colton's line, which I'm going to do in this case. So I'm just going to delete my line and these weird symbols, save, git status, git commit. In this case, git add foo first, git status. Okay, all conflicts are fixed. Here, if I do git status, Git confirms that all conflicts are fixed. Now all I need to do is git commit, and it's going to open up the text editor showing commit message, save, git log again. Here's the merge commit that we had, and if I open foo, now my Colton's new line is actually the one that's there.
Nice. So I'm just moving the chat at Babak Knight's request. It's a little bit obtrusive. And it looks like Elias also has a question too.
Yeah.
How to remove a file from Git without removing it from your file system?
How do you remove a file from Git without removing it from the file system? That's a good question. I think you would need to do two things here. The first one of them is actually remove the file from the repository using git rm, and then ignore the file using git ignore to have Git not track this file again.
Sure, makes sense. Is there a way to avoid Git from actually even trying to merge in that case, referring to the merge that we just tried to resolve, or some way of detecting potential conflicts?
That's a great question. I think there's a way to abort the merge in this case. Let's see. What are we looking at? Let's see. Okay. Let's try to reset the state of this to the previous commit, maybe. So let's git reset hard to the previous commit, which is 039D whatever log. Okay, now, oops, nope, that didn't work. What do we want to do? Okay. Okay, so we're now at on the previous commit in this case, which is in which case, like food didn't have anything. Weird. Okay, so let's do this again real quick. I messed up something here. New line, right? That was the one on master. And if I switch back to, let's add this. Let's add this, commit this, added, new line. Switch back to fix a bug. Check out new fix bug, get branch. Now, if I show what's info, I should see, okay, I should have added something else there. Check out master, sorry about that. My new line in this case. My new line, check out fix bug. Okay, so now if I try to merge this, I should still see a merge conflict. Okay. I actually lost track of something, so added new line. That's, which command is this? Oh, we are still on fix bug, so we should probably switch out to master first, because that's the branch that we want to merge into. So git checkout master, git merge, fix bug. In this case, I should still see the merge conflict. And I think, is there git merge dash dash abort? Yep, there you go. So if you do git merge dash dash abort, I think it just cancel the merge and not show any merge conflicts right here.
And so that'll just keep whatever was in master?
Yes, correct.
Okay, that makes sense. So this merge conflict is done when two people are working on the same file. Am I getting it right?
That's correct. Same file, and actually same part of the file. Because if you're working on different parts of the file, Git knows how to merge these changes.
Cool. All right,
okay.
What's next?
That's great. So we resolved merge conflicts. I wanted to actually briefly demonstrate collaborating with someone, so working on GitHub essentially, and for that we're going to need GitHub accounts. So I have mine here, which is a fake account.
And you want me to collaborate with you in this case, right?
Yep, I hope GitHub doesn't like this.
That would be unfortunate.
Yeah. Okay, so the main thing that we need to understand about GitHub is that it's a hosting service, which means what GitHub does for us is actually allow us to have a sort of remote copy of our repository and history on their servers, so that everyone can, sync with that remote copy, push changes to it to save it somewhere else, so it's not just on your local system, fetch new changes from it, and so on. So for that, we're gonna need a GitHub account. If you're new to this, you should go to github.com/join to create your account. I just signed into mine here, and the way to create a new repository, I think, is by clicking on this little plus icon here, and then choose new repository. And I haven't thought about the name, so I'm just gonna call it Frosh IAMs. In this case, I'm gonna make it a public repository. I think GitHub might allow you one pre-private repository. I don't remember. I'd have to check this out.
Yeah, I think it was a limited amount, like 2 or 3 or something like that.
Yeah. So if you'd like your repository to be private, not publicly accessible on the internet, you should probably mark it as private. In this case, I just don't care, so I'm going to have it as public. Create a repository.
By the way, it says, cool, that's a lifesaver for the git merge abort or whatever it was, right?
Yep, definitely. Yeah, definitely. I mean, it's definitely entirely like a completely valid case. That you want to, hey, change your mind and I don't care about these changes anymore, so you can just abort them as easily. Yes, so now that we have this remote copy of our repository, it doesn't have anything in it, obviously. And GitHub is trying to be helpful here in like giving us some instruction on how to get started with this. In most cases, people might have actual code on their local file systems, and we just need a way to tell GitHub, hey GitHub, or we need a way to tell our local repository that, hey, you should be syncing up with this remote repository from GitHub. And the way to do this is by adding a remote. And the way we add a remote is git remote add, I think, and then we should choose a simple name for this remote. By default, it's going to be origin, I think, and then the URL of the repository. So we can just copy this from here, paste it here, git remote add origin, and then this. If this worked as expected, we should do git remote -v to list the remote repositories. And in this case, Git saying, hey, I'm going to be syncing with this particular GitHub repository from GitHub.
Nice, and so now we've established that sort of connection. We can push to them and get code from them.
Correct, and notice that Git is actually listing these separately for fetch and push. And this is because it's actually possible to read from some repository and push to some other repository.
I think you have a server or something that you want to push
yeah,
to.
So suppose, I mean, we're going to briefly talk about forking soon, but suppose you want to contribute some open source project on GitHub. You want to ideally sync with this project, as well as your project, but you could literally set the fetch URL to be the upstream or the original project on GitHub. And instead of pushing to that one, which ideally wouldn't be allowed, you can just push to yours, or your copy of it, your fork.
Nice. Looks like we had a couple comments. Un3 Okapi, if I'm pronouncing that right, says, whoa, is that David Blaine on the right? Do you know who David Blaine is? Are you familiar?
No idea, I'm sorry.
Here, real quick, this is very important. David
Okay.
Blaine. This is David Blaine right here. He's a very famous magician.
Oh, interesting. He's not bald, though.
Here, I'll show. Go to my screen for a second, so we can see some pictures of David Blaine.
Wow.
I think he has been bald occasionally.
Oh.
He's got a shirtless picture.
How'd you get rid of it?
I don't know. Well, maybe he was never bald. Maybe he's just had really short hair at times.
Maybe.
But
Yeah, that's fair.
David Blaine and GitHub, everybody.
I also
Check
think
him out.
I have short hair all the time.
Yeah.
But anyway.
Oh, another comment. GitHub is basically like a storage facility for our files. So can we both put stuff there without sharing our username and password?
Definitely, yes. I mean, if you had to share your username and password every time you put something in GitHub, that wouldn't really be ideal. So yes, you can put stuff there without sharing any usernames or password. You can give people access to it without sharing your username and password with them, which is a neat feature as well. But GitHub is actually not just a storing facility. GitHub has a lot of features. We'll hopefully explore them briefly. Yeah, so we're going to see about this. So now that I let my local repository know that, hey, you should be syncing up with this remote repository on GitHub, one thing I can do is simply push my current branch, which is master in this case. So the way to do this is git push origin, which is the name of my remote, as we can see here on the left, and then master, which is the name of my local branch. Right? So if I do this, hopefully if the internet helps, like cooperates in this case. Okay, so I'm seeing a prompt right now for my username and password because obviously I don't like anyone to be able to push to my repository. So in this case, I'm going to provide my username, which is CS50 student2, my password, which is, I'm not going to say it online. Yeah.
Dream the
Well,
dream.
it's a fake account anyway. Yeah, it's something like that. Okay, so now Git confirms that it pushed my changes to my remote repository. If I refresh this page, I should hopefully see my master branch exactly the same way, or has exactly the same content as my local master branch has.
Nice.
At this point.
Like a file system view of all the files on that snapshot.
Yeah.
The most active snapshot.
Not just that, I think you can actually work directly within GitHub and edit files and stuff, which is really...
That's true. Yeah, there's a little pencil icon there. The chat's blocking it. But.
Yep. Yeah. It's a really cool interface to browse your repository or browse other people's repository without necessarily having to have a local clone of them.
A lot of other things like issues, pull requests, projects, a lot of different features too.
Yeah, we can probably, like, we can briefly introduce some of these features. Before we do that, though, I wanted to mention a point on cloning a repository. So suppose Colton is completely new to this and he wants to make some contribution to my repository or just wants to get a local copy of my repository to experiment with it. The way to do this is by clicking this, getting the URL of the repository, copying it essentially, and if I go to a separate directory here, temp, I could do git clone, paste the URL, enter, and it cloned my repository, and notice it also cloned the history of my repository, which is really neat. And this is what we meant earlier by this previous version control system.
Everybody, whoever downloads your program, your repo, has all of the history and therefore their own sort of version of like the entire version control system.
That's exactly right. And the cool thing though is that you are actually in control of this, so you can actually clone only certain branches or even only certain number of commits from these branches without, like, imagine a huge repository with a huge history. It's going to be really difficult to download on some networks, so you could just clone a limited number of these.
Sure, yeah, makes sense.
All right, so do you want to switch to your computer now to make a tiny change?
Sure, okay, so we'll go to mine. I'm going to go to my GitHub. By default, it's going to show my dashboard here. So I want to go to your repo, right? So what's the URL of your repo again?
The URL of my repo is github.com/CS50student2
CS50student2
/frosh.ims.
/frosh.ims, okay.
And we mentioned earlier that not, like, random people on the internet won't have, not that Colton is random people, but any other username or GitHub username won't have push access to this repository. So what probably Colton wants to do at this point is actually fork this repository or create his own copy on GitHub first.
Okay.
So the first thing you need to do is actually click on the fork button on the top right.
Okay, so this button right here?
Yep, I don't think it shows up here.
Oh, it's not visible in the chat there. Okay. We'll just hide the chat just for a second.
Okay.
Whipstreak says, I can't believe that's Colton from the lectures. Can you edit the code from Docker? Whipstreak, thanks for tuning in.
I'm actually using a Docker container right now. I'm inside of a Docker container, so yes, you can use Git or edit your code inside of a Docker container.
Awesome. Thanks for joining us. I'm going to go ahead and hide the chat box just for a second.
Okay.
So that we can see the web browser in its entirety. And then you said, okay, so click this fork button right
Yep.
here, right? Okay, I'm going to click that fork button.
And
where should we fork it? I'm an owner of multiple organizations on GitHub. We won't talk about that.
Okay.
I'm going to, not an owner, but an admin rather. I'm going to fork it.
It's going to take a while.
Personal account. Okay. So now I can just clone it, right? Like you said, go down here. And now I'm seeing that now it says github.com/coltonoscopy/frosh.ims, no longer CS50 student 2.
Exactly, because this is your own, as we mentioned, copy of this repository on GitHub.
Nice. Okay. So when I make push changes to this, you won't be able to see them, will you?
Nope, I won't be able to see them until you actually create something called a pull request, as we'll soon see.
Okay.
Okay, so the way to do this is to switch where you want to clone this.
In the game stream folder from yesterday.
Okay.
Okay, so I'm going to go into my dev. I'm just going to, and streams, and then I'm going to, I guess, clone it right into here, right? So git clone, which was a command that you showed before.
Correct.
And then I just paste in that URL, that .git URL.
Yep.
And then clone it, and then boom, I have everything. So now if I hit ls, I should see I have the frosh.ims folder.
Yep.
I can cd into that frosh.ims folder,
Yep.
hit ls again, and now I notice that I do have all the files that were in that repo.
So now maybe you can have, like, make any changes, like open any of the files, add any lines, or add new files. Colton can follow the same workflow that we have been following so far.
So I don't think I have a fancy CLI editor, but I'll use Nano on like application.py maybe, which is.
I honestly don't know how to use Nano except for saving.
It's a pretty bare bones editor. But let's just say that I wanted to maybe add a comment at the top or something.
Sure.
So I go up here, do that, and then Colton's version, and then
Okay.
I can save it with Control X, Y, Enter.
Get status to see what changed.
Right, and so
Okay.
now we see the same red message from before,
You
which
can
says modified, although it's red here, and I think it was green. Oh, was it green for you before?
No, it becomes green when it's added to the staging area.
Right, yeah. Okay.
So you can do git diff actually to see what changed.
Right, so git diff, and then we'll see, indeed, it's a little bit, since my editor's
yeah.
or my terminal color scheme is green.
But it shows a plus sign in this case
Yeah.
in front of it.
So Colton's version, and then this blue stuff. I forget exactly what this means.
I think this
Did we cover
refers to ranges of the file that are changed. So in this case, I think the first line, the third column, or I don't know. Yeah, the first line, I guess, or removed 3 characters, added 5 characters, or whatever. I don't know.
Yeah, I'm not sure either.
But yeah, it refers to certain ranges of line numbers and columns in the file, essentially.
Okay. Cool. So then now I've done it. Git status. I've made the change, but I haven't actually committed it, which is what we did before.
Correct.
Right?
Before you commit it, though,
no, we're good. Okay. Look like the video signal dropped out.
Okay.
Okay. So now I want to commit, right?
You can do. You have to stage it first, I think. So.
Oh, I think you can just commit, right?
You can do this in 1 step, but usually people do it in 2.
Oh, I don't. I usually commit directly. That's okay. All right. Walk me through this. Walk me.
So
through
git add application.py.
Okay.
And now if you do git status again, you should see this in green.
Right.
Now this is staged.
Committed.
This is ready to be committed. If you do get commit -m and then your commit message.
So Colton's version.
You don't have to add the A.
Oh,
the
right.
A is actually
to add as well.
To add as well, yes.
Okay, so that's why I guess I always commit, because I always do the -a flag.
Yeah, the downside of -a I think is that it doesn't count for untracked files.
Oh, I always git add those manually. So
Okay.
I guess my workflow is a little bit different.
I mean,
But
it's
that's okay.
if you think that change is trivial enough to like git add and commit at the same command, you can obviously do this.
Maybe it's better practice to do it the way that you're describing.
I personally always do git add first.
I don't think I've set my. I thought I set my config yesterday, but I guess it's not set. But that's okay.
You can just copy these commands if you want.
Global user dot name. Whoops.
While you're doing this, I'm gonna try to answer this question. So suppose I clone something from user1, made changes, add commits to save on the main person stuff. Won't it mess up the original repository? I don't think so. This is completely gonna be on Colton's copy, both locally and remotely. And we'll see now, what if Colton later wants to actually propose these as changes to the original repository? So we'll explore this in a bit. So I guess you're all set up with...
So I committed, and I can push now if I want to.
Can you see git log just to verify that you
sure.
commit? Okay.
Yep.
Awesome. Okay, so there's your commit. Now you can exit this using Q, then git push. Okay, so this is actually, it pushed right now. Previously I was more verbose and specified origin master. Truth is, Git doesn't always know what the default remote branch should be. That should be synced with this current local branch, because recall they're separate. And so you could always configure this using, and my computer got logged here. You can always configure this using git push -u, lowercase u, or --sit upstream, I guess, to sync like local and remote repositories with each other, branches with each other. Okay, so now that Colton pushed, can we check your GitHub repository?
Sure, let me switch the view to my laptop right there. Go back to Chrome, and then refresh the page. And it still kept the John Harvard name on this this account.
Okay.
Git config doesn't seem to be working on this user. I have to figure that out.
Yeah, probably you have. There are multiple levels of configurations, so probably you have a narrower scope. Okay, so now that Colton has, can you open application.py just to verify that?
Sure.
It has your comment in it? Okay.
Very top.
So suppose Colton thinks that these changes should be actually added to my repository, my copy of the repository in GitHub. One way Colton can do this is by actually opening a new pull request. And the way to do this is if you go back to the repository, yep, there's a new pull request, as you can see, here, right here.
Oh, sorry, here, rip.
Yep.
Okay, creating a new pull request.
And notice that it's recognizing my repository right here on the top left.
Oh yeah, the base fork, yeah.
Yep. So it's saying that, hey, it's gonna try to sync or try to apply these changes to this branch from the original repository. And now Colton can create a new pull request.
And it also shows the change
Exactly.
here too.
And this is also one of the nice features about GitHub. It shows you a graphical interface for what we practically were able to see using Git log. Oh, sorry, Git diff in this case.
Okay.
So if
now I
you
can
verify, create a new pull request, you're going to have to give it a title. By default, it's the commit message,
Okay,
and you're
that's
going to you can specify more details if you want. And the nice trick about this is that GitHub actually uses some version of Markdown here. So if you, for example, type anything, and like suppose this description, more specific description for my pull request, your pull request in this case, if you click on preview, this is what's going to show, right? If you go back to write and then add a hash in front of this, it's going to convert it to a heading.
Nice.
So you can do, like, there's actually a GitHub guide on these markdown tricks that you could do to format your detailed pull request in a neat way. And so once you're happy with all your changes, you could just click create pull request one more time. Now, ideally, I'm going to see this. If I have notifications actually enabled, I should receive an email about this. But ideally, notice that pull requests here are 1. If I go to this tab, I'm going to see Colton's pull request, right? And also, a few neat features of GitHub, I can assign this pull request to certain people to take care of. I can review this pull request. I can give it certain labels if I want. I can add custom labels too, and so on. So these are some neat features. You can add
continuous integration, which we might talk about next week.
We might talk about continuous integration deployment,
soon.
Maybe, yeah. That would be also neat. Okay, so I can also comment on the pull request. This had nothing to do with the code whatsoever. Like, we can just add, hey Colton, I'm expecting this to be like this, or that's good job, or any other number of comments that I could add about this comment, about this pull request. Once I'm happy with Colton changes, notice that I also can see what changed using the file changed interface here, button, tab. If I go back to conversation, and then once I'm happy, I can just click merge, confirm merge, and now I've actually merged the changes from Colton's remote repository. If I go back to my repository, open up application of Pi, I can see Colton's comment here. So this is pretty much it for pull requests. There are also features that Colton alluded to earlier, and these are more like, well, if you want to create a bug report for something in this project, or if you want to request a feature, or if you want to ask a question even, you can also use the issue feature of GitHub to create a new issue. And notice this interface is pretty similar to the one that you had briefly for a pull request, and it also uses the same Markdown version, so you can just also format it in a good way. Yeah, I think that's pretty much it for GitHub. One more thing that I think we should show that I actually forgot is, well, I guess we're at a perfect time to show this. So now that I'm in my, let me get back to my repository for Rush IAMs. Now, actually, if I do get log locally, I don't really see Colton's commit here in this case. So the way to sync up with my version of the repository in GitHub is using the git pull command. So if I do git pull origin master, or if you converted this, it can do this for you by default. If I do git pull origin master, hit enter, it's going to fetch the changes from the remote repository now. If I do git log again, I now see your commit. If I open application of Pi, go to the top line, I can see your comment.
Now we're all synced up.
Yeah, we're all synced up. So this is one workflow that people follow to collaborate.
Says, original user has the final say. That's very cool.
Yeah, definitely. I mean, imagine like we have pretty much an infinite number of open source projects. Imagine that anyone can do anything to them. That would be pretty bad. So it's good to have this sort of permission model and restrictions.
But you have the ability to contribute to anybody else's code if they approve of it.
Correct. Yes, that's absolutely true. All right. I think that's all what I have for now. We can stick around for a few more questions.
Yeah, let's stick around for just a couple minutes for some questions.
Okay.
But yeah, thanks for coming in to give us talk
thank you so
on
much.
Git and GitHub. And thanks everybody who tuned in today. We have 15 viewers here. We had upwards of 20 at some point. So
that's great.
Some good numbers.
That's exciting.
A lot of regulars in here today too. But yeah, and so on the horizon, you said you might have some potential other topics you want to talk about?
Yeah, we should. We should. At least we should probably talk about some continuous integration deployment techniques and tools. That would be interesting, I think. And that's something that we are actually using besides Git and GitHub here at CS50. And it's basically, long story short, the idea is we are able, through these tools, to automate some of the testing and deployment of our projects, which is really cool. One thing that I just remembered is talking about how Check50 and Submit50 work.
Right.
They are built on top of Git and GitHub. So they essentially do something like this. So committing your changes, pushing them to a remote repository underneath the hood, just in a slightly different way, but they essentially use the same principle to push your code to some of our organizations on GitHub or accounts on GitHub. And from there, we actually do some automation to actually create these automatically.
Yeah, I think a lot of people would probably be interested in seeing a more thorough walkthrough of like how Submit50 or Check50 works.
Yeah. By the way, they're actually open source as well on GitHub. Like, so you can go to github.com/cs50/check50 and see the latest version of Check50 right now, or Submit50 to see the latest version of Submit50. Submit, did I spell that right? Yep, there you go. So that's Submit50 as well.
D-Mail pushed the last commit there.
On August 15th.
Merged a pull request, which we just talked about.
Yeah.
We got a couple comments in the chat there. Did you answer the question about suppose I clone? Yeah, you did the clone one.
Yeah.
Does the repo have to be public, or original user can share a link if it's private?
That's a great question. So, in case it's private, anyone that's going to try to clone this repository is going to fail to do that. Like Git is going to refuse to clone it. GitHub is not going to allow this data to be given, I guess. So if I go back to my Frush IMs, if I go back to the settings tab, suppose this is a private repository, which is not in this case, but suppose it's a private repository, I can click on settings, I can click on collaborators here on the left, and then here I can actually add usernames like Colton's copy, right? Is that your username?
Colton's. You're missing a T.
Oops, sorry.
Colonoscopy is slightly different.
Wait, colonoscopy?
It's a coltonoscopy. I think you wrote colonoscopy.
I did write Colton first.
OSCOPY?
That's not true. Okay, do you want to spell it?
Is it not working?
Yeah, that's awkward. Okay, there you go. Okay, I was spelling it incorrectly.
Oh, I couldn't read it from here, so.
Okay, so I can specify Colton's username, add as a collaborator, and once Colton accepts this invitation,
I think I'd have to go into my...
Yeah, do you want to switch yours first here?
Would I have to go into my email to do that?
Not really. You can just go to the same repository, which is mine in this case, /invitations.
Okay. Oh, /invitations on the repo?
I think so. There you go.
Nice, okay.
And then you can accept. I mean, I think you do receive an email about this as well.
Yeah, I think that's where I usually click it to accept it.
So now, if you go back to my screen, if I reload the page, now I see that Colton's actually a collaborator here.
And if this were, now I can actually like push directly.
Now he actually has push access to my repository. In this case, I remember there was once a menu that allows you to give read-only access to the repository.
I think I remember that as well. Yeah.
I don't see it here, but it might be present in other contexts. But usually there is a menu that lets you give people even like read-only access to this repository.
Irene has another question there too, if you want to read that one off.
What would you recommend forking a project as opposed to creating a new branch? So these are two different things. Forking a project is creating a copy of some project into your own GitHub account, while creating a branch is something that we do within a project. So these are slightly different, if that makes sense.
And then, can you change the GitHub name like Frush IMs? I was not able to change it.
I guess if you go to settings options, you should be able to change the repository name, so long as you don't have a repository within your own account with the same name. So that should be possible as well. So settings, options, and then repository name.
I think my mic has been dead this whole time. I just realized, which is great.
Wow, nobody commented on that.
Yeah, Dan just slacked me.
Okay.
So, well, we're almost at the end of the stream, so I'll just piggyback off your microphone, I guess.
It's interesting, no one commented on that.
Yeah, I'm not sure why.
Maybe it got, maybe, I don't know, it interrupted in the middle of the stream. Okay.
Yes. Yeah, pretty cool.
All right. What other questions do we have?
Oh, we were talking about the things you might work on in the future.
Yes. Yeah. So I think we described, briefly talked about this. Yeah. So we're gonna be probably using a service like Travis CI to automate some of the testing and deployment of some of our projects for us. And by that I mean, suppose you have, I don't know, the CS50 library, for example. We ideally want to add some unit tests to this library that checks that the functionality of the library actually works as expected. And ideally, every time someone pushes to this repository, it's going to automatically run these tests and indicate some failure if they failed, if one or more failed, or success otherwise. Then by deployment, I mean, hey, once this is all ready, we can just push a new version of this repository, new version of this library to whatever service, PyPy, for example, in case it's a Python library.
Cool. Yeah, and I know on Friday we're having I'll be doing another game stream, so the memory card game. And then one of our teaching fellows, Nick Wong, who's in the chat, might pop in. Potentially, we're going to talk about doing some machine learning, some
cool.
AI stuff. If anybody's interested in that. But as always, if anybody does have any suggestions for particular topics or streams or anything that you'd like for us to do on camera or program on camera or whatnot, definitely let us know, because we have quite a few folks who have different specialties around here. So,
last question: what is an organization on GitHub? That's a great question. An organization is a slightly different type of account on GitHub. So, for example, in CS50 we have the CS50 organization in this case, and that's because we don't want to host all the projects that we work on in someone's account. So an organization allows us to do this, host more than one repository without actually hosting them in one individual account.
And then Bhavik has another question there too.
I want to know about tmux. Is that inside the IDE 50? Would it let me allow multiple terminals? Can I do something like that on PC? I'm not really sure about the PC options. There might be something like tmux, which is a terminal multiplexer in this case. I use one here on Linux, which is indicated by this really green bar at the bottom of the screen, which I don't think we can see right now. But tmux, yes, is a terminal multiplexer. Essentially, it allows you to create more than one terminal window within the same window. And yes, it exists on the IDE,
he's not doing anything on his computer.
but I don't think you need it really on the IDE because you could always create a new terminal tab pretty easily. But yes, it should be installed by default in the IDE.
Cool.
So is that a separate account? Yes, the CS50 organization is actually, you can think of it as a separate account type that more than one of us has access to it. I guess you could create a new organization somehow. Let's Google this real quick. Yep, so GitHub actually has a very useful help guide here that lets you know how to create a new organization.
Is that a premium feature? Can you do that with a free account, or do you need to have a?
That's interesting. So if I go to settings,
I guess maybe it would be like you could have public repos on it, but private repos are probably you need a premium premium account.
Yeah, I think I haven't actually tried to create one before, so let's experiment with this. First IAMs, if you go to settings, or is it account settings? It's account settings, I think. Why did I go to the repository? Okay, organization is here, okay, new organization, and then
Okay, it looks like you can, free, yeah, and then you have to pay for the other ones, it looks like.
So it looks like it supports unlimited public repositories, but for private ones you'd have to pay a monthly fee.
TIL.
Yeah.
All right, well, it's going to be about 5 o'clock. We'll probably end up closing it off here.
Okay, thank you so much for having me. This was really
Yeah, thanks for coming on and doing it. If anybody is watching this on YouTube after the fact, definitely come follow us on twitch.tv/CS50TV, where you'll be able to join the live chat in real time and talk with us, and then maybe we'll do some collaborative stuff in the future. David J. Malin in the chat, everybody. Whipstreak, you can say hi to him right now.
Hi, David.
Bella, Kira, Kareem, and Colton, thank you for an interesting stream. Thanks for coming, Bella. Appreciate it. Thanks, David, as well. And thanks, Whipstreak. Thank you. Very informative, says Bavik. Thanks, Bavik, as always. And then Nick says, thanks, guys. Powerhouse of the cell. So
thank you so much.
There we go. All right, cool. Thanks, everybody. We're going to close out now. And again, as a reminder, we're going to have a stream again on Friday where we do the memory card game. Last word, Kareem?
That's exciting. I want to thank you all, and yeah, see you next time.
Cool.